Good morning, I'm Dror Feitelson and I'm going to present our research on reanalyzing empirical data on Java local variables with narrow and broad scope. So we all teach our students that they should use meaningful variable names in the programs that they write. And it's also widely agreed that naming may depend on scope. So in a very narrow scope, such as a loop, you may use I for a loop index. But if you have a wider scope, like a long function, you probably need a longer name to express the intent of the variable. There has been surprisingly little research about this issue, but a couple of years ago, Hiroshi Aman and co-workers published a paper about this topic. They collected data about more than 600,000 variable names from nearly 1,000 open-source Java projects from GitHub, including the length and the scope of these variables. They also analyzed the names by dividing them into words and classifying these words. In their analysis, they compared variables with a broad scope, which they defined to be the 90th to 99th percentiles of the scope distribution, with other variables. They found that half of the variables in the broad scope were compound, meaning they were composed of multiple words, and an additional third were full words. There were relatively few single-letter names, I and V being exceptions. They also found that broad scope variables tend to be slightly longer, and that abbreviations and short words tend to be used to control the length. When I read this paper, I thought that there was a lot more interesting stuff that can be found in this data, and this paper reports what I found. The main idea is to look at all the scopes using logarithmically spaced bins. So the minimal scope is up to 2 lines of code, and then we look at scopes up to 5, 10, 20, and 40 lines. The broadest scopes is those variables that had more than 40 lines of code, up to 380. Variables which had a scope of more than 380 lines are probably part of automatically generated code and not interesting, but those are only 0.1% of the variable names. Note that scope is measured from where a variable is defined to the last line that the variable is valid within a function. The data does not include variables with global scope like class members. We start by analyzing the name types. These are dominated by 3 classes of names. Around 40% of the names are single dictionary words, and they do not change much with scope. Single letter names are very common at the minimal scope and are about a third of the names there. They become increasingly less common as the scope increases. This is made up by compound names, which are only 1/4 of the names in the minimal scope and grow to be more than half of the names at the broad scope. If we divide compound names into words and look at all the words from all the names together, we see that dictionary words dominate. Single letters are used more often in lower scopes, but exist also in wide scopes. Words derived from types and abbreviations are used equally in all scopes. Numbers are used more often in wider scopes, but their absolute numbers are very low. Turning to name lengths, we see that names will become progressively longer as the scope becomes wider. This is true whether we measure length in words or in characters. Interestingly, the distributions of name lengths for the different scopes overlap. All of them start with names of only 1 letter and extend to names with more than 20 letters. However, when the scope is wider, the distribution of name lengths is shifted a bit to longer names. Looking at the histograms of name lengths in the different scopes, the most prominent feature is the single letter names. These are very dominant in the narrow scopes and all but disappear in the broad scopes. We can also see that the tail of the distribution in the broad scopes become heavier due to having more compound names with multiple words in them. Going on to abbreviations, we find that abbreviations are applied to relatively long words of 6 to 14 letters and reduce their length to around 3 to 5 letters. However, we find that this is done in all scopes and not just in broad scopes. Finally, we look at name popularity. This table shows the 30 most popular names in the whole dataset. These tend to be generic words like result, value, entry, index, or name. However, unexpectedly, there are many single-letter names, not just I as a loop index. These include C, N, S, T, B, R, M, P, A, V, F, and X. If we list the 50 most popular names for each range of scopes, we can see how the popularity of names changes with scope. Some names turn out to be used more often in broad scopes. This includes I, probably a loop index, index itself, result, C, count, type, name, X, and more. Other names are used less often in broad scopes. Many of these are single-letter names. For example, E representing exceptions, J probably a nested loop index, T, B, V and the full word value, and more. In addition, there are many names which are full words and are used only in narrow scopes and not in wider scopes. Examples include listener, message, field, ignore, container, and more. If we look at words, we see that words that are used in many different names achieve high popularity ranks. For example, name by itself is the 16th most popular variable name, but it's the 3rd most popular word. Numbers like 1 and 2 are also popular, especially in wider scopes. Interestingly, 2 is more popular than 1. The distribution of the popularity of names is a Zipf distribution. If we rank the names by popularity, the popularity of the name at rank k is proportional to 1 over k. This leads to a straight line when plotted on double logarithmic axis. The distribution of the popularity of words is not Zipfian. The vocabulary is limited, and popular words are much more dominant than popular names. The distribution of popularity is a Zipf distribution, which is very skewed. The most popular names dominate. In our dataset, less than half of 1% of the different names make up half of all the name instances. Interestingly, this concentration depends on scope. Popular names are much more dominated in narrow scopes. In broader scopes, they are somewhat less dominant, implying that the distribution is a bit less skewed. To conclude, we provide a detailed portrait of naming in open-source Java projects and how it relates to scope. We replicate and extend the results by Aman et al. We agree that names in a broader scope tend to be longer, composed of more compound names and fewer single-letter names. We also agree that long words tend to be abbreviated. However, we do find a new result that many different single-letter names are used. These results open directions for future work. One possible direction is to investigate the reasons and implications of different structures and different scopes. For example, it is interesting to investigate whether longer names are really necessary in broader scope. Another interesting research direction is to look at single-letter names. What are they used for and how does this correlate with scope? Thank you. I also want to thank the authors of the original study for collecting the data and making it available, and also to encourage all of you to make your data available and perform replication studies.